Batch forming has real value in formula development, but one common misunderstanding appears again and again. If the batch trial works, people assume the same formula should also run directly on a continuous slabstock line. But once it reaches the actual line, many people find that the result is not the same. The reason is not complicated. Batch forming and continuous slabstock line production may follow the same basic formulation logic, but they are not the same process condition. Batch forming is a small-scale verification under laboratory conditions. Continuous slabstock production is a scaled-up process running under actual equipment conditions, line speed, machine structure, and continuous operation. Once the production scenario changes, mixing state, reaction rhythm, heat build-up, and cell formation all change with it. So even with the same formulation, the batch result and the actual line result are never guaranteed to be the same. That is exactly why the real value of batch forming is not to predict final line performance directly, but to check whether the direction is right first. What it mainly tells you is this: is the formulation route reasonable, is the reaction trend correct, and are the basic properties worth taking further into scale up? In other words, batch forming is more like an intermediate judgment step between theoretical formulation and continuous slabstock production. Its job is to screen direction, not to replace later line judgment. This is also why some formulations may look good in batch forming, but still need further adjustment after they go onto the continuous line. That does not mean batch forming is meaningless. It means batch forming was never meant to solve every problem on the continuous line. What it answers is whether this route is worth taking forward, not whether the line result will be exactly the same later. But there is one more condition here. Batch forming itself must be kept as stable as possible. Otherwise, even its role in checking direction becomes weaker. Whether raw material weighing is accurate, whether the addition sequence is consistent, whether premixing condition is stable, whether temperature is under control, and whether mixing time and mixing speed are repeatable, all of these directly affect batch results. Many differences that look like formulation problems may not really come from the formulation numbers themselves. In the end, they may come from inconsistent batch forming conditions, so batch results cannot be treated directly as continuous slabstock production results, not because batch forming is unimportant, but because its task was never to replace line judgment. Its job is to eliminate routes that are clearly wrong and keep the systems that are worth scaling up. Once you move into continuous slabstock production, the next step still has to be judged again together with equipment conditions, drop plate, machine width, and line speed. In the next episode, we will move on to the next question: how does a base formula become a continuous slabstock production formula? And how do equipment, drop plate, machine width, and output rate reshape that formula? If you want more practical ways to handle common formulation issues in continuous flexible PU foam production, comment just below. We'll share the document, 8 Practical Adjustment Approaches for Flexible PU Foam in Continuous Foaming Production. You can also download it directly from the link in the video description.